Ay, nako, mali.
Hi mga hands!
She's Nonny.
And she's Tracy.
And for today's video, we're going to talk about
Atom. So first, what is atom?
Atoms are the building blocks of chemistry. It is the smallest particle that completes a matter.
So there are three subatomic particles, and these are...
The first one is the protons, the positively charged particles found inside the nucleus. Next is the electron, the negatively charged particles found in the electron cloud outside the nucleus. And last are the neutrons, which are the neutrally charged particles that can easily adapt to the protons or electrons.
just like this cookie. It is made up of different ingredients.
So wow!
But how did the concept of atom came about?
Democritus believed that the smallest particle, which we now call atom, cannot be divided into smaller pieces. He called it atomus, which means uncuttable, but people rejected his idea because of lack of evidence. Fast forward to early 1800s, a school teacher from England, named John Dalton, studied about chemistry and discovered that atoms do exist. In his atomic theory, he discussed that atoms are, number 1, tiny indivisible particles, 2, atoms of one element are the same, 3, atoms of different elements are different, and lastly, compounds are formed by combining atoms. The first subatomic particle to be discovered is the electron by J.J. Thomson from his cathode radio experiment. Next are the protons and nucleus from Ernest Rutherford. However, he believed that there is an existence of another particles, the neutrons, which was later on discovered by James Chadwick. Another significant person in this lesson is Niels Bohr. He discovered that the electrons move around the nucleus in a specific layers or shells.
Now, how are we going to know the number of subatomic particles present in an atom?
Let's compute!
Pew! Pew! The element lead, the number of electrons and protons, will be the same as the element's atomic number, which is 82. To find its number of neutrons, we have to subtract the atom's number from the element's atomic mass. Another example is the element phosphorus, which has an atomic number of 15. So automatically, its number of protons and electrons is also 15. To find for its neutrons, we have to first identify its atomic mass, which is 30.9, or approximately 31. So subtract atomic number to its mass, and there we have found the number of neutrons. However, some elements of the same elements but have different mass number and number of neutrons do exist, and this is called
The isotopes!
the element radon has an atomic number of 86 and atomic weight of 222. So if to compute for its neutrons, the answer is 136. But if we have here the isotope 226, this means that the mass of the element radon is 226. However, its atomic number will still be 86. So if we subtract both numbers, the neutrons will now be 140.
Tara na. So that's all for today's video. Always remember that everything we have in this world is made up of things our naked eye can't see.
I hope you learned something today.
Thank you for watching. Bye, hands! That's all for today's video. Always remember that everything we have in this world is made up of things our naked eye can't see.
So I learned you.
So I learned you hope something.
So I learned you something. Delete that.
Ay, nako, mali.